we shall be doing equation of trajectory for a projectile motion. This we have taken as x-axis, this is y-axis. Over here we have thrown a body with the velocity u at angle theta. It goes like this. A few things what we had done earlier, let's say regarding projectile motion, is this is motion in 2 dimensions, and you break this velocity. The first part is break this velocity in 2 components along x-axis, u cos theta, and this is u sin theta, provided theta is with the angle of initial velocity with the x-axis. So this is u cos theta, this is u sin theta. The other thing what we have done is velocity is tangent to the path. Ay is equal to g directly downwards. Ax acceleration along x-axis is equal to 0. Acceleration along y-axis is g directly downwards. And over here the velocity at the topmost point, velocity along y-axis is equal to 0. The horizontal component of velocity remains same because ax is equal to 0, so that remains same. So those things we have done it. Now we are interested in writing down the equation of trajectory. Let's say at point T, it has coordinates x and y. A body reaches over here, this point, at time T it reaches and its coordinates there x and y. So what is x? X is obviously this distance only, and y is this distance only. So if I write it as Sx is equal to uxt plus half axt square. If you remember, we have taken upward vectors as a positive, downward vectors as negative. This way vectors as positive, this way vector as negative. Opposite vector kind of a thing. You know that is vector is a direction also. So over here Sx is equal to uxt plus half axt square. Now acceleration along x-axis we had done it, that is equal to 0 because there is no force along the x-axis. The only force which is acting is mg in the vertically downward direction. So component of this force at an angle of 90 degree is equal to 0, and that being the only force, so force along x-axis is equal to 0, that is fx is equal to 0, fx is equal to m into ax. If this is equal to 0, is equal to m into ax, m is not equal to 0, so ax is equal to 0. It's okay. Sx is equal to uxt plus half axt square. So this goes off. Sx, what is that? Let's say from here to here, we are considering point, let's say A to B. Let me write it. A to B. Sx is displacement along x-axis. How much? This is the displacement along x-axis. Right? Now we are just bothered about the x-axis. Do not be concerned about, let's say, what is the displacement along y-axis. That will come separately, as we have done in the earlier class. First you break the velocity along the x-axis, along y-axis. Then this is motion in 2 dimensions. Crudely speaking, you have broken, that is motion along x-axis and motion along y-axis to make the job easier. And then you are trying to solve it using the elementary method of, let's say, motion in 1 dimension like sine convention. So along the x-axis it has moved this much. What is Sx? X. Ux. Initial velocity, we are at A. Along x-axis is u cos theta. Suppose it takes time from here to here t. So t comes out to be x upon u cos theta. This I write it as equation 1. Now along the y-axis, I write sy is equal to uyt plus half ayt square. Sy is how much? Sy is y only, y coordinates. What is uy? U sin theta. This is initial velocity along y-axis is u sin theta. Upward means positive. Upward is positive. U sin theta t plus half ay. Ay is what? Ay is g directly downwards. Direct downwards is negative. So it is half minus g into t square. This I can write equation number 2. If I put the value of 2 in 1, sorry, 1 in 2, t, the value of t in this, so I get, that is y is equal to u sin theta, t is x upon u cos theta, half minus g, t square is x upon u cos theta, its whole square. The equation of y is equal to x tan theta minus gx square upon 2u square cos square theta. That is equation of trajectory for a projectile motion, which is moving under the action of gravity, purely moving under the action of gravity. Y is equal to x tan theta minus gx square upon 2u square cos square theta. Y is positive, x square coefficient is negative, so that means obviously from basic mathematics, algebra, coordinate equations, you know that is going to be a inverted kind of a parabola. It's okay, so this is equation, coordinate equation is, the representation of this is going to be parabola, so this path is going to be inverted parabola. Now how do we use it? Let's say if u is given, suppose I have thrown this body with the u as 20 root 2 meter per second at angle theta is equal to 45 degree, right? If you look over here, y is equal to x tan theta minus gx square upon 2u square cos square theta. The t we have replaced by x upon u cos theta. That is, we are now bothered about x, u, y coordinate and so on. So if u is given, theta is given, and I say that is where will the body, suppose x is equal to, let's say, suppose I say 10 meter. When the body has moved 10 meter forward, what is the height of this? That is, I am bothered with the y coordinate. So I put the value of x, 10, theta value is known, so tan theta is known, g known, x square known, u is known. Please understand over here, u is the value 20 root 2. Do not once again break into components. The value of u over here, you will not be putting 20 meter per second, but this value 20 root 2 meter per second, this whole value 20 root 2 value you will put. U square cos square theta, theta is known, you get the value, you will get the value of y. That is at what height it is going to reach when you throw it with the velocity 20 root 2 meter per second at an angle of 45 degree with the positive x-axis in the upward direction, and when it has moved 10 meter along the positive x-axis, at what height it will be. So directly using this equation of trajectory, you can get the height. Otherwise, if you don't remember it, within 2 lines, you can derive it and you can get the answer. So do not simply cram this formula, that is y is equal to x tan theta minus gx square upon 2u square cos square theta. You should be knowing it. That is how we have get to this equation, because this is nothing. This is not a complex equation. It is primarily using the basic concept of projectile motion. We have reached this formula.